this is this is MAT 175, lesson 31, section 7.1, inverse sine, cosine, and tangent functions. And as a review for the properties of functions and their inverses, we have this composite function here, f of its inverse and f of x. When you have these two inverses functions of each other, you end up with x. And that goes back to when we have something like this. If we had f of x is, let's say, this x squared, and its inverse is the square root of x, then if we had the composite function of the inverse of f of x, then it's like we're cutting the x out. And if we have f of its inverse, we cut that x out and we have just parentheses there. And then we fit in the f of x inside there, and these two functions are inverses of each other, you just get x. Well, the same thing holds true for trigonometric functions as well, where we have inverse sine of x, then, or whether it's x or theta, then our answer here would be theta. And so if we had sine of its inverse, theta, then again our answer is theta, depending whether or not our function is in the domain or not. And so we would have to take a look and see that. But generally, these two, inverse and sine, are inverse of each other, and so you end up with just the variable. Okay, so having said that, here we have a y equals 2 sine x function. And so if we were to look at this, and if we were to draw, here's our sine, comes up and down and around. Okay, we're familiar with that. And so the problem with this sine curve is that to determine, we know that this would be a function, but would its inverse be a function? And its inverse basically would look something like this. Well, we can see that the inverse is not a function. This would be y equals to inverse sine x. And so we use to determine if a function and its inverse are 1 to 1, we use the horizontal line test. Well, we see here that sine does not pass the horizontal line test. In other words, sine and its inverse are not functions. Yeah, they're not functions. They would not, either one of them. Its sine would pass the vertical line test, but its inverse would not. So these functions are not one. Sine is not 1 to 1. So what we have to do here is we have to restrict sine, and we do that by going to just pi over 2, and then we go to negative pi over 2 in the other direction. So we can say here that, and what happens at that point is its inverse is going to be, we get this negative pi over 2, we would get this here at pi over 2, and this would continue on around here to negative pi over 2. And notice that, so for sine, we get our domain. Now we're purposefully restricting the domain so that now the sine does pass the horizontal line test. it is 1 to 1. And so we would restrict the domain for sine to negative pi over 2 to pi over 2. And the range for y equals to sine x, that's going to be from negative 1 to positive 1. And so what was on the x-axis, which is pi over 2 and negative pi over 2, is now on the y-axis. And so now this is for y equals to inverse sine x. So now our y has the pi over 2 to negative pi over 2. And our domain for y equals to sine x, our range rather, is negative 1 to 1. So now for our inverse sine, that would be negative 1 to positive 1 for our domain for our inverse. So here we have our y equals to inverse sine x. Our domain was the range for sine. So our domain is negative 1 to positive 1, and our range is what was once our domain for sine is now our range for our inverse sine. So this would be negative pi over 2 to pi over 2. And so we need to have these domains. We have to look at these domains when we're trying to solve problems in order to be able to, if anything that's outside of these domains when we're solving problems would be considered no solution. So these domains are important for us to know. Alright, so with that, here, so we've eliminated the other halves, and that gives us this part here. This part here is here. And so we can see that our domain, we're restricting our domain from negative 1/2 to positive 1/2. And that's what this is here. Okay, so this would be our domain, negative 1/2, or pi over 2 rather, to pi over 2. And here's our range. And that's negative 1 to positive 1. Okay, only they put it in an inequality form, and we're putting it in interval notation form. And so this is what it looks graphically, and here we see that it passes the horizontal line test, and so we have the our sine curve is now 1 to 1 when we restrict that domain. Okay, so here is y equals sine in red, and here's that negative pi over 2 to pi over 2, and we can see here that the y equals to sine x as a domain of negative pi over 2 to pi over 2, and the range is negative 1 to positive 1. And the inverse, y equals to inverse sine, just think of it this way. What was the range for sine is the domain for its inverse. So that would be domain for the inverse sine is negative 1 to positive 1. And what was the domain for sine is now the range for inverse sine. So that would be negative pi over 2 to pi over 2. Alright, and so here's our inverse. Here's at pi over 2 to negative pi over 2 for the inverse, and positive 1 to negative 1 for the inverse. So we can see that when we put in this axis of symmetry, the graphs are symmetrical about the axis of symmetry. Okay. Find the exact values of the inverse sine function. Okay, so here we have inverse sine of 1. And so first thing we have to do is determine, is it within our domain for inverse sine between -1 and +1, which it is. So what we want to do here is we want to look at this as we know in the past that if we had sine of, let's say, some angle, let's say pi. Okay, well, here's pi, -1 for cosine, 0 for sine. So we know that this is our angle, and our value for sine at pi is 0. So this is our value. Alright, so here for inverse, we're given the value and we're trying to find the angle. So we look at our unit circle to see where is sine, inverse sine, going to be at 1. Well, we have to stick with our domain from pi over 2 to -pi over 2. Well, sine, if this is 1, 0, 0, 1, 0, -1 for cosine and sine, well, in this case here, sine is, because it's only a +1, it can only be at pi over 2. And so that's our answer. Because at pi over 2, sine is 1, our value is 1, and our angle is pi over 2. So here we're given the value, and we're looking for the angle. We're restricted to look at between -pi over 2 and pi over 2, and we know that our sine is going to be 1 at pi over 2. And here it is. That's our answer. Okay, find the exact value of inverse sine function. Alright, we know that for -1/2, we have to look at our domain has to be in our range for inverse sine. We have to have, if we're looking at y equals inverse sine x, our domain has to be between -1 and +1, which we're in there. -1/2 is in between -1 and +1. So this is our value, and so we can look at this and say, alright, inverse sine is -1/2 if this is square root 3 over 2 and -1/2 for cosine and sine. What angle is that? And you should have said that this is going to be a negative pi over 6. Now it's not, so we're looking at the value and we're trying to get the angle. And so we see here at -1/2, we're given the value and we're trying to find the angle. So we're trying to find, the angle, which is going to be -pi over 6. Okay. Find an approximate value of an inverse sine function. Alright, so express the answer in radians, rounded to 2 decimal places. So here, this 1/3 is not part of our special angles. It's not part of pi over 6, pi over 3, pi over 4, pi over 2. It's not any of those. So we have to use the calculator, and we have to round it to 2 decimal places. Well, and we want our angle in radians. So what mode do you think you need to be on your calculator? You should have said your mode on your calculator should be in radians, not in degrees, because we want our angle in radians. So that's how you can tell if your mode is either going to be in radians or degrees. Here it tells you it wants the angle in radians, so your mode has to be in radians. So we need them in radians for both. Alright, so with this is 1/3 within our domain for inverse sine. And what was our domain for inverse sine? You should have said between -1 to +1. So we're okay. Alright, and so we put that in our calculator, and we get 0.3398, and it goes on. We want to round that to 2 decimal places, so that'll be 0.34. Alright, so here we're going to go ahead and put the sine, -1/4. That's also within the domain for inverse sine, and that's also in radians, and so we get -0.25. It's like 2 decimal places. Alright, so that's the main thing that you've got to watch out for in the previous example is that you're within the domain for inverse sine. Alright, so here you're always looking, when you have properties of inverse functions, when you have inverse sine and sine, you're going to do the sine first. So you have to make sure that you're in the domain of the internal function. Since here, sine, you're given the angle here, and we always know that in the past when we had sine of, let's say, pi over 4 is square root 2 over 2. We were always given the, get rid of that y there. We were always given the angle in the past, and we wanted the value. Alright, so whatever you're looking at inside the parentheses, you have to make sure you're in the domain. So for sine, we have to make sure that we're within the -pi over 2 to pi over 2 domain before you can go any further. If you're not, then your answer is no solution. Alright, now here we're given the value. So for sine, inverse sine of, let's say, 1. Here you're given the value, and you are looking for the angle. Alright, and so sine is going to be 1, right, at pi over 2. Well, the domain for inverse sine is -1 to +1. So you have to make sure, so for sine, your domain are the angles, -pi over 2 to pi over 2. For inverse sine, your domain are the values, because you're starting with the value. So if this number here is, let's say, a 2, then there's no solution because you're outside of the domain for sine. Okay, so with that, let's take a look at this. So here's sine pi over 8. So are we within the domain for sine? Well, we're in between the -pi over 2 to pi over 2, so the answer to that is yes. And so since this is within the pi over 2 to pi over 2, then we can say that inverse sine and sine is going to be pi over 8. They're inverses of each other and you get your angle. Well, the problem here is that well, let's see. Are we within the sine value for y equals to x? Are we within the negative pi over 2 to pi over 2 domain for sine? Well, we're not, because 4 pi over 8 would be considered pi over 2. So we're outside the domain. Well, maybe at this point, right now we're outside the domain. But here's 4 pi over 8, and here's, so that's the same as pi over 2. And here's 5 pi. Here's 5 pi over 8. Well, this is pi, right? So that'd be the same thing as 8 pi over 8. So if we can find this angle here, then we can say, alright, that for sine, the values are the same whether it be in quadrants 1 or 2. So if we can find this angle here, then we can say, alright, that's the same values as if the angle is over here. So we take 8 pi over 8 minus 5 pi over 8, and we get 3 pi over 8. So that would be the same thing as if we were to say this angle here was 3 pi over 8. And so that's what they did here. See, 5 pi over 8 is not within the interval, so we can't look at that. But we know that in quadrants 1 and 2, sine are the same values. So we see that if this is 5 pi over 8 here, this is 5 pi over 8 here, then if we were to subtract that from 8 pi over 8, we could get 3 pi over 8. Well, 3 pi over, for sine, we can see they're the same values. So we could say, alright, we'll subtract 5 pi over 8 from 8 pi over 8, we get 3 pi over 8, and that puts us in our domain of negative pi over 2 to pi over 2. And so when we say that, we can say, alright, we can change sine 5 pi over 8 to 3 pi over 8. And that's what this is here. And so now sine and its inverse cancel each other out, and our answer is 3 pi over 8. Okay. Here we have inverse sine of 0.5. So what is our domain for inverse sine? For inverse sine of x, you should have said negative 1 to positive 1. Well, is that within our domain? You should have said yes. It's in between negative 1 and positive 1, so we're okay there. So sine and inverse cancel each other out, and our answer, what's that going to be? You should have said 0.5. Okay. Now here, inverse sine is 1.8. Well, is that within the domain for inverse sine? It's outside, right? It's greater than, it's outside of negative 1 to positive 1. So in that case, we would have to say no solution, because we're outside of the domain for inverse function. So it's okay to change it for our angles, but not for sine, but not for its inverse sine, like we did in the previous problem. Okay, now inverse cosine. Here we know that in the past, inverse cosine, or cosine rather, started off, came up, stopped at pi over 2. But it does not pass the horizontal line test. It is not 1-to-1. So we have to restrict the domain for cosine. And so here for cosine, we can go from 0 to pi. And now it'll pass the horizontal line test. And that's what we did here. So therefore, our domain for cosine is going to be, from 0 to 1 pi. And we can see here that our range, well, what do you think that is? You should have said our range is from -1 to +1. Okay. And so our inverse cosine is going to be switched. So basically what this comes down to is for y equals to cosine x, our domain is 0 to pi, and our range is -1 to +1. And for y equals to our inverse cosine, what was the range for cosine is now the domain for inverse cosine. So that'd be -1 to +1, and what was the domain for cosine is now the range for inverse cosine. So that'd be from 0 to pi. And so here we have it. Here's y equals to cosine, goes from 0 to pi, and that's range is -1 to +1. And what was on the x-axis is on the y-axis for inverse cosine. So here's pi over 2 for x, now it's pi over 2 on the y. And pi for the x is now pi for the y-axis. And it goes from +1 to -1. So here's our inverse cosine, our graph for our inverse cosine. Alright, so now let's take a look, find the exact value for inverse cosine at 0. So we want to say, alright, if we have our unit circle here, here's 1, 0, the cosine and sine is 0, pi over 2 is 0, 1 for cosine and sine, and negative for at pi, -1, 0 for cosine and sine. And we want to know within from 0 to pi, okay, inverse cosine, the domain for inverse cosine is -1 to +1, so that fits within our domain for inverse cosine. So our angle, since this is a value, cosine has a value of 0 at what angle? You should have said at pi over 2. Alright, and so here we have it. Cosine has a value of 0, so our angle is pi over 2. Alright, and there we go, there's our answer. Alright, so we're looking for a, here we have inverse cosine at -√2/2. And so we know that for our domain has to be from 0 to pi, but we can say that because we have that inverse cosine is within a domain of -1 to +1, -√2/2 is greater than a -1, but less than a positive 1, so it fits within our domain for inverse cosine. So another way to look at this is on the unit circle. If square root 2 over 2 and square root 2 over 2 for cosine and sine is pi over 4, then you have to have a negative square root 2 over 2, positive square root 2 over 2 for cosine and sine has to be in quadrant 2. Well, this would have to be 3 pi over 4 here to get that angle. And so that's why the answer is at 3 pi over 4. Alright. So cosine fits within our domain for cosine. Our domain for y equals to cosine x is between 0 and pi. So we ask ourselves, is 5 pi over 6 within that domain? And yes, it is. So we can say that cosine of 5 pi over 6 and inverse cosine, that would give us just 5 pi over 6. So inverse cosine at point 2, is that within our domain for inverse cosine? Well, inverse cosine domain is negative 1 to positive 1. And we can say yes. So cosine and inverse cosine, that would give us 0.2 for an answer there. Alright. And then the next one, cosine at 5 pi over 4, is that within the domain for cosine? Well, the domain for cosine is 0 to pi. So that's outside of the domain. So in that case, what we have to do is look at, if this is 4 pi over 4, here's 5 pi over 4. So we want to see what, if we were to look at this angle here from the x-axis, and it's always in reference to the x-axis, to this angle here. If we can find that angle, then we could also say, alright, that we could use that within our, that would be the same value as if we were in quadrant 2 for cosine. So that would be pi over 4. So 5 pi over 4 minus 4 pi over 4 gives us just pi over 4. And so we could see here that that would be the same thing as 3 pi over 4. So because we need to be in quadrant 2. The values for 5 pi over 4 would be the same as they would be in quadrant 3 as they would be in quadrant 2. Because if we were to look at it in here, 5 pi over 4, this would be negative square root 2 over 2, negative square root 2 over 2 for cosine and sine. Well, over here, at 3 pi over 4, it would still be negative square root 2 over 2 for cosine. So that's why we want to choose 3 pi over 4. And so now, therefore, the cosine and sine are inverses of each other, and they cancel. And they cancel each other out, and we end up with 3 pi over 4. And this last one here, inverse cosine is at 2. That's outside the domain for cosine, between negative 1 and positive 1. So it's undefined. It's not within the interval negative 1 to positive 1. Okay, tangent. Here, we're restricted, again, now for tangent is 1 to 1 between tangent and its inverse, so it passes the horizontal line test for one interval. So we can say that the domain for tangent is between negative pi over 2 and pi over 2. And so the range would be negative infinity to positive infinity. And so we would go ahead and use that in our finding exact values for tangent. And so tangent at 1 would be at pi over 4. Our value of 1 for tangent would be an angle of pi over 4. Negative square root 3 is within that, and it fits within the angles of negative pi over 2 to pi over 2. So negative square root 3 would give us a negative pi over 3. And here it is down here.